For 99 years, the Nürburgring Nordschleife has served as the supreme court of the automotive world. It is 20.8 kilometers of tarmac that snakes through the Eiffel Mountains, earning the moniker the Green Hell from Sir Jackie Stewart. For decades, a hierarchy existed here that was as rigid as a caste system. If you wanted to break a record, you needed a badge from Stuttgart, Maranello, or Woking. You needed a century of combustion heritage. You needed engineers who had gasoline running through their veins. The idea that a consumer electronics manufacturer, a company that was assembling smartphones and air purifiers just 5 years ago, could enter this sacred ground and humiliate the establishment was considered physically impossible. It was a joke. Until January 2026, the Xiaomi SU7 Ultra did not just arrive at the track. It arrived with a declaration of war. When the telemetry came back showing a lap time of 6 minutes and 46 seconds, the silence in the boardrooms of Germany was deafening. To understand the sheer magnitude of this violence, we must contextualize the numbers. This four-door saloon is faster than the Porsche 918 Spider hypercar. It is faster than the McLaren P1. It is knocking on the door of the Porsche 919 hybrid Evo race car. This is not merely a fast lap. This is a complete dismantling of the Western value proposition. European manufacturers have charged us millions for heritage, and soul. Xiaomi has proven that heritage is irrelevant in the face of superior physics. They have exposed the uncomfortable truth that the legacy automakers have been resting on their laurels, iterating slowly, while the Chinese technology sector has been treating the car not as a mechanical object, but as a high-velocity software platform wrapped in aerospace-grade metallurgy. Today, we peel back the skin of this machine to understand exactly how they did it. The greatest limiting factor in high-performance electric vehicles is the structural integrity of the rotor within the motor. In a permanent magnet synchronous motor, the rotor is laden with heavy rare earth magnets. As rotational speed increases, centrifugal force grows exponentially, not linearly, at 20,000 revolutions per minute. The force trying to tear the magnets away from the central shaft is equivalent to several tons of pressure. If the containment fails, the motor essentially turns into a fragmentation grenade, destroying the drivetrain instantly. This is why the Tesla Model S Plaid is electronically limited to roughly 20,000 RPM, and the Porsche Taycan slightly lower. It is a material science limitation. Xiaomi's engineers, however, refused to accept this ceiling. They targeted a stratospheric 27,200 RPM for the HyperEngine V8s. To achieve this, standard industrial materials were useless. They had to develop a proprietary ultra-high-strength electrical steel alloy with a yield strength of 960 megapascals. For comparison, the titanium used in aircraft landing gear sits around 800 megapascals, but the steel core was only the beginning. The industry standard for keeping magnets in place is a technique called wet winding using carbon fiber. Xiaomi rejected this. They developed a laser-tensioned dry winding process. This technique wraps the carbon fiber sleeve around the rotor with such immense pre-tension that it physically compresses the internal components before the motor even spins. This pre-compression counteracts the centrifugal expansion at high speeds, keeping the rotor dimensionally stable within micrometers of tolerance, even at 27,000 RPM. The result is a motor with a power density of 10.14 kilowatts per kilogram and a peak efficiency of 98.11%. They have effectively built a centrifuge that powers the wheels. A motor capable of such violence is nothing more than a paperweight if the energy storage system cannot deliver the current required to feed it. This brings us to the most critical metric in electric performance: the C rate. The C rate represents the speed at which a battery can be safely discharged relative to its total capacity. A standard electric vehicle operates between 2C and 4C. The industry benchmark for high performance was previously the Porsche Taycan Turbo GT, which pushed these limits significantly with its 800-volt architecture. However, the Xiaomi SU7 Ultra utilizes the CATL Qilin II battery pack, which features a revolutionary chemical structure allowing for a continuous discharge rate of 16C. Let us pause to appreciate the thermodynamic violence of that figure. At 16C, the battery is capable of dumping its entire energy capacity in under 4 minutes. It delivers a peak output of 1000 sajanash, 330 kilowatts. That is nearly 1.8 megawatts of raw power. According to Joule's first law, the heat generated in a conductor is proportional to the square of the current. Dealing with this level of amperage generates enough thermal energy to melt standard copper bus bars and boil conventional coolant. To solve this, Xiaomi and CATL completely redesigned the thermal management architecture. Traditional EVs utilize a bottom cooling plate strategy. The Qilin II employs a dual-surface active cooling system, circulating coolant not just beneath the cells, but between the rows and over the tops, increasing the thermal transfer surface area by 60%. This allows the vehicle to run at maximum attack on the Nurburgring without entering thermal derating modes. Furthermore, the internal resistance of the cells has been reduced to near superconductor levels, ensuring that energy goes into the motors rather than being lost as waste heat. Even at 20% state of charge, this battery can output 800 kilowatts, more power than a Bugatti Veyron possesses with a full tank of fuel. Speed in a straight line is simply a question of horsepower. Speed in a corner is a question of managing the atmosphere and the chassis flex. The Xiaomi SU7 Ultra weighs approximately 1,900 kilograms. Physically, a heavy object traveling at high velocity wants to continue in a straight line due to inertia. To force it around a corner at 200 kilometers per hour requires a force greater than gravity itself. The aerodynamic package on this car generates a staggering 2,145 kilograms of downforce. This means that at top speed, the air pressure pushing the car into the tarmac weighs more than the car itself. Theoretically, this vehicle could drive upside down on the ceiling of a tunnel, but downforce typically comes with a penalty: drag. To resolve this conflict, Xiaomi implemented a sophisticated active aero system. The U-shaped rear diffuser is not static, it modulates airflow actively. The rear wing adjusts its angle of attack in milliseconds, slashing drag on the straights to allow for top speed, and deploying as an air brake in the braking zones to stabilize the rear axle. Beneath the skin, the chassis is equally revolutionary. Following the path laid out by Tesla, Xiaomi utilizes massive die casting machines, gigacasting, to create the rear floor assembly. By casting the rear chassis as a single piece of aluminum alloy, they eliminate hundreds of welding points and potential points of failure. This results in a torsional rigidity of 51,000 Newton-meters per degree. For context, the Bugatti Chiron sits around 50,000. The McLaren P1 sits around 40,000. Xiaomi has built a chassis stiffer than a multi-million-dollar hypercar for a fraction of the price. This extreme rigidity ensures that the suspension geometry remains perfectly aligned under high G loads, allowing the Michelin tires to extract every ounce of mechanical grip available. The most underrated aspect of speed is the ability to kill it. Bringing a 2-ton projectile from 350 kilometers per hour to zero generates a thermal event equivalent to a small explosion. Kinetic energy scales with the square of velocity, meaning the energy required to stop the car grows exponentially as speed increases. To dissipate this energy without vaporizing the braking components, Xiaomi partnered with Akebono to install the largest carbon ceramic brake discs ever fitted to a production saloon. The front discs measure 430 millimeters, clamped by massive 6-piston monoblock racing calipers. These pads and discs are designed to operate at temperatures exceeding 1000 degrees Celsius, glowing bright orange, without fading or glazing. However, the mechanical friction brakes are merely the final line of defense. The primary stopping power comes from the regenerative braking capabilities of the motors themselves. The HyperEngine V8s can switch from propulsion to generation in milliseconds, providing up to 0.6 Gs of deceleration force purely through magnetic resistance. This is aggressive enough that a skilled driver can navigate technical sections of a track using one pedal, modulation, shifting the weight of the car forward to bite into a corner without ever touching the brake pedal. This seamless integration of software-controlled magnetic braking and hardware-based friction braking solves the inconsistent pedal feel that plagues many hybrid supercars. They have effectively turned the braking system from a mechanical hydraulic loop into a digital control interface. We cannot discuss the SU7 Ultra without discussing where it comes from. Critics often point to the panel gaps and build quality issues of early Tesla models as proof that tech companies cannot build cars. Xiaomi anticipated this criticism and built the Xiaomi EV factory in Beijing to be the most advanced automotive manufacturing facility on the planet. The factory utilizes over 700 robots in the body shop alone, achieving 100% automation in key areas like welding, painting, and assembly. But the true innovation lies in the inspection process. The factory employs an XI, Intelligent Inspection System, which uses high-resolution cameras and artificial intelligence algorithms to scan every millimeter of the vehicle's bodywork and chassis for defects with a precision of 0.05 millimeters. This is tighter than the human eye can perceive. By removing the human error element from the quality control process, Xiaomi ensures that the structural integrity of every SU7 Ultra matches the prototype that destroyed the Nürburgring record. They are not just building cars, they are printing them with industrial precision. This level of automation also explains the price point. By vertically integrating the supply chain and automating the most expensive labor processes, Xiaomi can sell this hypercar performance for a fraction of the cost of its European competitors. It is a triumph of process engineering, as much as it is a triumph of automotive engineering.